Welcome to ISM 6404, Business Intelligence and Business Analytics. This class is being taught by Dr. Ernesto Lee. So, in this first lecture, we're going to explore the foundational concepts of business intelligence, or sometimes called BI, and business analytics, or BA. These disciplines have become essential for organizations that want to remain competitive in today's data-driven environment. Business analytics, it addresses the evolving need for insights that are derived from vast and complex data, enabling companies to make better and faster decisions. We're going to begin by discussing the importance of business analytics in responding to organizational challenges and opportunities. I want to highlight the transition from traditional decision-making approaches to approaches that are kind of powered by data and advanced analytics tools. This lecture is also going to introduce some key frameworks and architectures that underpin business intelligence systems. We're going to clarify the distinctions between BI and BA using examples to illustrate how each is applied in practice. Additionally, you're going to learn about the broader business analytics ecosystem. And this ecosystem, it encompasses tools, processes, and stakeholders critical to extracting value from data. Finally, we're going to review available resources that will guide your learning journey throughout the course. And by the end of this lecture, you're going to have a solid foundation to build upon as we delve deeper into the world of BI and BA. Now, organizations today, they must also contend with managing and analyzing massive data sets, commonly referred to as big data. Now, the challenge lies not just in storing large amounts of data, but also in deriving actionable insights from it. Data warehouses and advanced analytic solutions, they have become indispensable in this regard, enabling companies to sift through mountains of data efficiently. Analytical support tools, they help decision makers understand trends, make predictions, and identify opportunities which would be impossible to achieve manually. Now, these tools are designed to complement human intelligence, especially as we face cognitive limits when processing large and complex data sets. Also, knowledge management systems play a crucial role in ensuring that critical organizational knowledge is captured, organized, and shared effectively. And this fosters an environment where employees and teams can collaborate seamlessly, building on one another's expertise. The need for flexibility and real-time access to tools and data has also driven the demand for anywhere, anytime support systems. These systems empower business leaders to make informed decisions on the go, regardless of their location. And together, these evolving capabilities, they address the challenges of today's dynamic business landscape and equip organizations to thrive in a data-driven world. The evolution of computerized decision support systems, it reflects the growing complexity and demand for data-driven insights in business environments. So starting in the 1970s, organizations relied on basic decision support systems, DSSs, and they provided routine reporting and static analysis. Now, these early systems were primarily focused on structured data, and they were also very limited in scope. By about the 1980s, the focus shifted to enterprise information systems, and they offered tools like dashboards, scorecards, things like that, so you can have better strategic oversight. Now, these systems allowed organizations to manage resources more effectively and to make informed decisions at an executive level. The 1990s, it saw the rise of data warehousing and business intelligence. And this marked a huge leap in storing, managing, and analyzing vast amounts of data. BI tools made it easier to access real-time information, to generate insights across all the organizational levels. And if you move on to the 2000s, you have advancements like cloud computing, software as a service, data mining kind of laid the groundwork for the modern era of analytics and big data. The 2010s, it brought new dimensions with the integration of social media analytics in database processing and powerful data science tools. So this evolution has transformed decision-making into a dynamic and proactive process, equipping organizations with the ability to predict trends, to uncover opportunities, to optimize strategies, to do all of this like never before. Let's look at a framework for business intelligence. The framework for business intelligence, it provides a structured approach to turning raw data into actionable insights. Now, at its core, the framework, it revolves around a centralized data warehouse, which you see right here. At its core, it relies on a centralized data warehouse. This data warehouse, it collects, it organizes, it stores data from various sources through processes like ETL, extract, transform, load. This centralized repository, it ensures data consistency and data quality. And this all makes the analysis more reliable. Now, from the data warehouse, you often will have these data marts over here. And they often cater to specific departments or specific functions. They offer a tailored subset of data to meet specialized needs. And alongside the metadata that you see over here, it's going to give you essential information about the data about the data. It's going to make it easier to understand and to query effectively. Okay, it's going to make the reporting that much stronger. Now, the output of this framework, it supports a wide range of business functions. You're going to have tools like, OLAP, online analytical processing. You'll have a bunch of dashboards that you can create from here that'll give decision makers this kind of interactive and real-time insights. Clearly, there's going to be financial reporting, predictive analytics to kind of enable the organization to monitor the current performance and anticipate future trends. In addition to this type of framework, alerts are going to be important. Notifications, workflow integrations, all of this is going to be important to make sure that we have a timely response to critical changes, whether that's through spreadsheets or broadcasting tools or portals. The BI framework ensures that stakeholders across all levels of an organization have access to the insights they need to make data-driven decisions. Now, this interconnected system is the backbone of modern business intelligence. It's delivering value across diverse business operations. The architecture of a business intelligence can be visualized as a system that connects data, users, and decision-making processes in a single integrated flow. And it all starts with data sources, where raw information is collected from various internal and external sources. This data flows into the data warehouse environment where the technical staff takes charge of organizing, summarizing, and standardizing the data. The data warehouse is acting as a centralized hub that ensures data consistency and data quality, making it accessible for analysis. Now, once the data is prepared, it enters the business analytics environment where business users can access and manipulate it to derive insights. And these insights are then going to be funneled into the hands of managers and executives who rely on them to make strategic decisions and to drive performance through tools like business process management strategies. And this entire process is supported by a user interface. And this user interface can take the form of dashboards, portals, browsers, making this system user-friendly and accessible. Now, as BI evolves, intelligent systems are becoming a key future component, enhancing decision-making by incorporating AI-driven insights. This architecture, it ensures a seamless flow from the raw data to actionable business strategies. So this slide here, it's highlighting the key differences between transaction processing and analytic processing. They're two distinct yet completely interconnected components of modern business systems. Now on the left side over here, on the left side, we have transaction processing. And it's focusing on simply capturing the day-to-day data from business operations. For example, a product database, it might record updates, like adding a new product or changing its price. Similarly, an advertising database could log changes to ad schedules or budgets, and a consumer demographic database, it might track updates to customer credit limits or salary levels. But the primary goal here is simply data capture, making sure that all of the business activities are recorded accurately and stored for future use. Now on the right side, you have the analytic processing over here. And it takes the captured data and it transforms it into analytical insights. That's very important. It's very important. It's doing this so that it can support decision making. This is where business intelligence comes into play. For instance, analytics can answer questions like, how many products were sold due to TV ads last month? Or, which customer demographic is performing best for product A? These insights guide strategic decisions such as optimizing inventory or tailoring marketing efforts, while transaction processing ensures that data is systematically collected and stored in a data warehouse. Analytic processing leverages that data to support high-level business decision-making, driving better performance and efficiency. And together, they form the backbone of data-driven organizations. For business intelligence to be effective, it has to be closely aligned with an organization's overall business strategy. So proper planning and execution, it involves integrating BI into the business organization functionality and the infrastructure. And this makes sure that BI initiatives are not just standalone tools, but they contribute to the organization's strategic goals. By connecting BI with these foundational elements, organizations can achieve better coordination and execution of their strategies while driving value from their data. And one way organizations ensure this alignment is through what's called a BI Competency Center, BICC. And it plays several key roles. First, it ensures that BI efforts are directly linked to the company's strategic objectives. And this helps to guide decision-making at all levels. The BICC, it also fosters collaboration by encouraging interaction between business users and the IT or IS teams, the information technology or the information systems teams, kind of bridging the gap between, let's say, technical and business perspectives. Additionally, this Business Intelligence Competency Center, BICC, it acts as a central hub for best practices, making sure consistency and knowledge sharing happens across different departments or business lines. And lastly, it promotes standards of excellence. In BI practices, advocating for a culture of data-driven decision-making throughout the organization. So this structured approach is what ensures that BI not only supports, but actively drives achievement of business goals. So the concept of real-time, on-demand business intelligence, that's no longer a futuristic goal. It's a reality today. With the emergence of real-time BI applications, organizations can access live data and insights to make quicker and more informed decisions. For instance, tools like dashboards, like maybe a Gecko board or something like that. This is going to let businesses monitor key metrics like customer support performance as it happens in real time. And this ability to access up-to-the-minute information can provide a competitive edge, especially in fast-paced industries where timely decisions are critical. However, implementing real-time BI requires careful consideration. It's important to justify the need. Is the investment in real-time capabilities, is that worth the additional cost and complexity? For some organizations, the value is going to lie in the immediate action, such as maybe optimizing supply chains, such as responding to customer complaints or managing inventory in real time. And to achieve this, companies can leverage enablers, like maybe RFID, so that they can track assets, web services, for instance, for seamless data integration, and intelligent agents that automate the analysis and delivery of critical insights. Now, these technologies collectively make real-time BI attainable, empowering organizations to move from reactive to proactive decision-making. Analytics, it plays a central role in modern business decision-making. At its core, analytics is the process of developing actionable decisions or recommendations by uncovering insights from historical data. And this isn't just about looking at the past, it's about using patterns and trends and relationships in the data to guide future actions. For example, by maybe analyzing past customer behaviors, a company can tailor its marketing strategies, or it can improve product offerings to better meet customer needs. Now, according to the Institute for Operations Research and Management, INFORMED, it's a pretty good acronym, Institute for Operations Research and Management Science, INFORMS, analytics combines computer tech, management science techniques, and statistics. Combines all three of them to address real-world problems. And it's this combination of tools and approaches that allows businesses to move beyond intuition and to make data-driven decisions. Whether solving supply chain challenges, whether we're optimizing resource allocation or predicting future sales, analytics provides a structured and scientific way to address complex issues and to create value across industries. So business analytics is often categorized into three main types, into descriptive, predictive, and prescriptive analytics. 1, 2, 3, descriptive, predictive, prescriptive. And each of these three, they play a unique role in helping organizations understand their data and use it to make informed decisions. If you take descriptive analytics, for instance, it focuses on answering the question, what happened? It provides insights into past events by summarizing data through tools like dashboards and scorecards and business reporting. For example, a company might use descriptive analytics to identify trends in sales performance over the past quarter. The primary outcome here is a clear understanding of well-defined business problems and opportunities. We also have predictive analytics. And with predictive analytics, it's forward-facing. It looks forward and it answers questions like, what will happen? Why will it happen? It leverages techniques like data mining, text mining, and forecasting to make accurate projections about future events. For example, a retailer might use predictive analytics to forecast customer demand based on historical purchasing patterns and external factors like weather or holidays. Now, at this stage, it helps organizations anticipate future trends and outcomes. We also have prescriptive analytics, and it takes it one step further by addressing what should I do and why should I do it. It uses advanced tools like optimization, simulation, and decision modeling to provide actionable recommendations. For instance, a logistics company might use prescriptive analytics to determine the most efficient delivery routes. And this would save both time and money, because the goal here is to enable the best possible business decision and action. Now, together, these three types of analytics, they create a robust framework that supports data-driven decision-making, enabling businesses to not only understand their past and predict their future, but also to take proactive steps to shape the best outcome. These are some concrete examples of how descriptive, predictive, and prescriptive analytics can be applied to real-world challenges. If you look at that car example, okay, the very first one right here, it's finding the best route to get home quickly. Descriptive analytics would analyze the past travel data like routes taken over the last week, average speed and time taken. And this would give you a clear picture of a typical travel pattern. If I'm looking just at this car example here, doing the descriptive analytics on this. If I move over to predictive analytics with the car example, it would use GPS systems to forecast traffic conditions, identify which routes might be congested based on the current and the historical data. And lastly, if I look to the right over here at prescriptive analytics, it would recommend the optimal route to take by considering traffic levels and providing alternatives that save time. There's also examples for social sharing and statistics and social sharing, but you can read. I'm not going to read those to you. You get the idea. Sports analytics, that has grown into a major specialty within the broader field of analytics, with the sports industry generating $145 billion in annual revenue. Data-driven decision-making has become essential to maintain competitiveness and to maximize performance both on and off the field. One of the most well-known examples of sports analytics was made popular by the book and the movie called Moneyball. The book was published in 2003, and the movie came out in 2011. And essentially the story revolves around the Oakland A's, a Major League Baseball team, and how they used analytics to revolutionize the way teams evaluated talent. So instead of relying on traditional scouting methods, they employed computer analysis to identify unconventional metrics like on-base percentage and slugging percentage. And these were found to have a stronger correlation with winning games. So by recruiting players who were great at these kind of overlooked areas and combining them with talented players proficient in other metrics, the Oakland A's, they managed to build a competitive team on a limited budget. Now, today, sports analytics, it goes far beyond baseball. It's applied to virtually every single aspect of sports, from optimizing team performance and managing injuries to enhancing fan engagement and maximizing revenue streams. But the principles established in Moneyball have paved the way for data-driven strategies across the entire industry. Here's another example of sports analytics. It involves an application beyond the field, specifically in the business office of sports organizations. One challenge often faced by teams is understanding why season ticket holders choose to renew or not to renew. So surveys, they give you good feedback. The reported survey scores about satisfaction or likelihood to renew, they don't always align with the actual percentage of people who end up renewing. So to address this discrepancy, organizations leverage analytic techniques like regression models, which identify factors that influence renewal rates. Churn models. These predict the likelihood of a customer not renewing. Sentiment analysis. What this does is it analyzes and looks at the underlying emotions and attitudes. These methods provide deeper insights into customer behavior, helping teams predict trends more accurately. Now, by understanding the reasons behind renewal patterns, organizations can create targeted strategies to improve sales, to increase renewals, to foster long-term fan loyalty. So this highlights how analytics is not just about game performance, but also plays a critical role in business decision-making within the sports industry. In sports analytics, it's not just about game strategies or fan engagement. It's also a critical tool for player health and performance management. You can think of trainers. The trainer's role is to keep the players healthy, to identify potential issues early, and to provide actionable advice to coaches about the team's physical condition. Now, modern technology plays a key role in this process. For example, players often will wear sensor-equipped vests. They'll do this during their training sessions. These vests collect real-time data, such as heart rate, body temperature, and movement patterns, providing trainers with a wealth of information about a player's physical condition. Also, tests like the single leg squat hold test or the core body strength test. These are used to evaluate a player's core strength and balance and stability. These tests can reveal key strengths and weaknesses in a player's body. And this will let trainers customize fitness plans, prevent injuries, optimize performance. They'll do this by leveraging this combination of wearable technology and performance analytics. Trainers can make sure that players remain in peak physical condition and are less likely to sustain injuries, directly contributing to the overall success of the team. And this is yet another example of how analytics has become an essential component of sports management. So analytics has found meaningful applications across a variety of industries. Healthcare is a particularly impactful domain. Companies like Humana Health Insurance, they use analytics to address critical challenges and to improve both patient outcomes as well as organizational efficiency. So let's look at a couple of examples of how they leverage data-driven insights. One example, Humana uses analytics to study patterns and risk factors that lead to falls amongst seniors. Now, by analyzing data on health conditions, medications, environment factors, by analyzing those, they can identify high-risk individuals and they can implement targeted interventions, such as balance training or maybe home modifications. This proactive approach, it not only improves the quality of life for seniors, but it also reduces health costs. Defining the right metric with Humana's bold goal, that's number 2. The second example, this focuses on improving community health. Analytics, again, plays a central role in defining and tracking the right metrics such as access to care, health equity, chronic disease management. So by monitoring these metrics, Humana ensures that their strategies align with their overarching goal of making communities healthier. Okay? And lastly, the last example is we can use predictive analytics to help Humana identify members who are at the highest risk of adverse health outcomes. These models analyze factors such as medical history, lifestyle, and claims data to predict which members may need additional care or early interventions. This enables Humana to allocate resources effectively and improve outcomes for at-risk individuals. And even though, through these examples, it's clear that analytics in healthcare is not just about data. It's not just about data. It's about a lot more than that. Okay? It's about making informed decisions that lead to better health outcomes and more efficient systems. Analytics plays a crucial role in the retail value chain also. It's going to enhance efficiency and decision making at every step, from vendors to customers. By leveraging data, retailers can optimize their operations, provide better customer experiences, and drive profitability. So look at something like vendors and planning. At the vendor level, analytics is going to help you with simple supply chain management. I say simple, but supply chain is anything but simple. It's going to reduce inventory shortages. It'll help with excess stock while cutting down on unwanted costs. And during the planning phase, data is going to be used for shelf space optimization, location analysis, promotion planning, making sure that the products are placed where they're going to drive the most sales. Let's look at merchandise and buying. Retailers are going to use analytics to fine-tune merchandising strategies such as creating targeted promotions, optimizing pricing, and providing customized shopping experiences. So for buying, trend analysis, category management, and forecasting demand is going to help to make sure that the right products are available at the right time, improving inventory accuracy and customer satisfaction. Think about warehousing and logistics. If you have efficient logistics, that's going to be critical to your success. And analytics is going to be what makes sure that you have on-time delivery of products while minimizing costs. Transportation costs are reduced by optimizing routes and consolidating shipments, and this will help retailers meet delivery expectations without inflating expenses. A lot of times we're going to have multi-channel operations, and then lastly, customers. Analytics, it supports multi-channel strategies by making sure you have a seamless customer experience across platforms. Insights into customer preferences, they're going to help you kind of tailor marketing strategies and improve services for customers. Analytics is going to build loyalty and retention. It's going to help retailers better understand and cater to their customers' needs, especially high-value customers. So by applying analytics at every stage of the retail value chain, businesses can make smarter decisions, enhance operational efficiency, and deliver greater value to their customers. All of this while staying competitive in a rapidly evolving market. The analytics ecosystem, it's a dynamic and interconnected network of key players, all of them contributing to the growth and the evolution of the analytics industry. So it's important to understand who these players are, what they do, and how you might find a place in this exciting field. At the center of this ecosystem is the analytics user organization. And this represents businesses and industries that actively use analytics to drive decision making. Now, surrounding this core are going to be different types of providers and stakeholders. There's going to be data generation infrastructure providers, data management providers. They're going to handle the collection, storage, and organization of your data. Your data warehouse providers, as well as your middleware providers, what they're going to do is they're going to give you seamless data integration and accessibility for analysis. Now, beyond the infrastructure, there's going to be a lot more than that. There's going to be analytics-focused software developers and application developers, and they're going to create the tools and platforms that empower organizations to use analytics effectively. Industry analysts and influencers, they're going to guide trends and adoptions, while the academic institutions and the certification agencies, they're going to play a key role in developing future talent and setting industry standards. Additionally, regulators and policymakers, they're going to make sure that ethical and legal implications of analytics are addressed. So for you, the ecosystem is going to offer a variety of roles and opportunities. You might identify as a consumer of analytics within an organization, a provider of tools, or a provider of services, or even an entrepreneur creating innovative solutions. This field, it also presents job opportunities in data engineering, analytics consulting, or policy advising. By understanding the landscape, you can find your niche while keeping an eye on the future of computerized decision support systems and the broader analytics industry. When we talk about big data analytics, it's not just about the size of the data, it's about the unique challenges and opportunities that arise when dealing with extremely large and complex data sets. Big data is typically characterized by the 3 V's, by volume, variety, and velocity. Volume is talking about the sheer amount of data that comes from a variety of sources like social media or IoT devices and enterprise systems. When I say variety, it's going to talk about the diversity of the data formats. And I'm talking about structured data like databases, unstructured data like images and text, and semi-structured data. Those would be like JSON files. When I say velocity, I'm talking about the speed at which data is generated and the speed at which the data needs to be processed. For instance, if you have a real-time data stream from sensors, or maybe financial transactions. So big data enables businesses to uncover patterns and insights that were previously unattainable, driving decision making. Techniques like text mining, machine learning, natural language processing, these are often used to analyze these massive data sets. So more details on big data analytics and tools, we're going to talk about those when we get to chapter 6. But on the right, on this slide here, you see the chart with the names and the sizes of the data units. And these are crucial for understanding big data. We commonly use terms like kilobytes, megabytes, gigabytes, but in the context of big data, we're often talking about much larger units. We're usually talking about petabytes of data or exabytes of data. Beyond that, there's even theoretical limits like the brontobyte of data and the gigabyte of data. And these represent unimaginably vast amounts of data. These metrics kind of help contextualize the scale of data in these modern analytic systems and how much they must handle. So we have to address these challenges and leverage the appropriate tools so that we can extract value from data, in particular big data, and use it to gain a competitive advantage. Okay, so we have explored the transformative impact of business intelligence and business analytics on organizations. We began by examining the foundational concepts of BI and BA, focusing on how they evolved to meet the challenges of a data-driven world. We went from descriptive analytics that summarizes past events to predictive analytics that forecasts future trends, and prescriptive analytics that recommends actionable solutions. This framework, it equips businesses to make informed decisions. I highlighted the importance of aligning analytics with business strategy to ensure that insights lead to meaningful outcomes. Throughout this lecture, we dived into the real-world applications across multiple industries like sports, healthcare, retail. In sports analytics, for instance, we saw how tools like predictive models and wearable technology, how they optimize player performance and fan engagement. Similarly, in healthcare, analytics helps organizations like Humana identify at-risk populations and define strategic goals, and data-driven strategies kind of streamline supply chains, and this optimizes inventory, and it kind of personalizes customer experiences. And this demonstrates the power of analytics at every stage of business operations. So I tried to conclude this lecture with an overview of the analytics ecosystem, including its key players and infrastructure and future opportunities. And I touched on big data analytics, so understanding its defining characteristics of volume, variety, and velocity, as well as the immense potential it offers organizations. So, by learning how to navigate the ecosystem and apply analytics effectively, you students here at FAU are equipped with the skills to contribute to this growing field of BI and BA. And as your professor, I encourage you to reflect on how these concepts can be applied to your career goals, making you a vital part of the data-driven economy. Thank you very much, guys. That's going to conclude this lecture, and I will see you on the next one. Have a great week.